Hi, welcome back to Logic. This is our third week, to our third and our final lesson this week, and that's the lesson of the concepts of Obversion, Conversion, and Contraposition. Now, conversion, aversion, and contraposition, these are three what we call operations, logical operations. This is when we take a statement and then we do something to the statement to get another statement. Now, you'll see that in certain cases, but not in all cases, when we perform the operation, the resulting statement will may or may not have logical equivalence. If there is logical equivalence, then that can often be very important for helping us understand how those statements work, and also help us understand when we hear something, if we perform an operation, we can understand if it's actually valid, even though it may not be in standard form, right? So I'm going to show you these operations on the whiteboard, so it'll be a little bit clearer if I write it down than if I just speak right now. Okay? Let's talk about what conversion is and how conversion works. Conversion is very simple, actually. Okay, so essentially what we have here, let's take a basic statement. Let's take all men are mortal. And we can represent this by saying that here we essentially have the quantifier, we have the subject, we have the copula, and we have the predicate. So we've combined all of our knowledge, right? Right? Now, conversion is very simple. Essentially what we do for conversion is we're really just going to switch the subject and the predicate. We just switch them. That's all we do. Right? Such that what would result in is that all mortals are men. Right? But you can see by doing conversion here, I'll just write this up here so you can see it. This is clearly false. Conversion actually does not work on an A statement, but it does work on other statements, right? So let's try a different, right? So let's try a different one. Let's try the no cats or dogs example, right? To convert it, we just have to switch the subject and the predicate, right? So this would say that no dogs or cats. Right? That's actually true, right? And so here what we have is that the truth value of this is logically related to the truth value of this, such that if this is true, this will also be true, right? Conversely, if this were false, which it's not, then we would also say that this is false, right? Okay, so our next examples, our next type here is what we call aversion. And aversion, unlike conversion, which only works on the E and the I, the aversion will work on all statements. So maybe we can just put that up there. It's going to work on all of our categorical standard forms. And it simply consists in this, right? And that's one. Well, let's take a statement here. All S or P. It's going to consist in really two different things. The first thing you have to do is you have to change the quality. Right? The second thing you have to do is you replace the predicate with the term complement. So we'll just put here, you replace P with its complement. Now, what is a class complement or a term complement? A term complement is really not it's like the logical opposite of the predicate. But when I say logical opposite, it's not the same thing as a real and actual opposite. Really, it's essentially saying you replace P with non-P, right? The complement is essentially anything that is not the term, right? So for instance, if let's say I had my P here, like if we had a Venn diagram, the complement would be represented by all the stuff that's out here. That would be the complement, right? That may not be a helpful picture I've drawn there, but definitely look at your book, which gives you some helpful diagrams. So replace the P with its complement. So let's do it, right? So if we change the quality, that means we have to change it from being positive into being negative, right? From affirmative to negative. So that means in this case we're going to write no. No S are non-P, right? So for example, if I say all police officers, right, are civil servants, then I could say no police officers are non-civil servants. And those actually have logical equivalence, such that if this one's true, this one will by definition also be true. Right? So this is the case of aversion, and you can avert any categorical statement and it will result in something that's true. Okay, so next we're talking about the next operation is contraposition. Right? And contraposition, right, essentially works by, let's take our example here, all S or P. And contraposition essentially works by two different operations. One, you switch the S and the P. Right? So we're going to do a switch. It looks like conversion, but there's a second step, which is namely that we replace both terms with the complement. I'll just write with C here for with complement. So we switch the subject and the predicate, and then we replace it. So what we get here is something like all non-P are non-S. Okay? Now, let's put it into a real life example. So what this says is, let's say, all police officers are civil servants, and this says all non-civil servants are non-police officers. And just by thinking about that, that actually makes complete sense. And what we're going to discover, which you'll discover as you do your reading and your homework, is that contraposition always yields logical equivalence for A and O propositions. A and the O. Aversion is for all of them, and conversion is for the E and the I, right? So let's write it out here for you, just so you can see it. Alright, so if we have conversion, right, what we end up with is it yields logical equivalence for the E and the I proposition. Aversion yields logical equivalence for the A, the E, the I, and the O, right? And contraposition yields a logical equivalence for which propositions? Do you remember? The A and the O, right? Now, if you remember our square of opposition, this is what's interesting, right? We had your A, the E, the I, and the O, right? And we said that these diagonals are contradictory. And what we see here is that what conversion does, right, is there's a relationship here between the contradictory nature of one, but when you convert it, you can get the opposite statement. And likewise, contraposition does the same. Aversion works for any of them, right? But it's fairly interesting, and you're probably wondering, where do these relationships all boil down to? Why do they work like this? The question, or the answer to that question, is ultimately that it concerns the distribution of the terms. So I hope you can see here that actually all of what we've been talking about here is all utterly related, right? Such that there is intricate relationships working together, right? And in terms of logic and in philosophy, right, the reason this isn't simply mathematics, but this is also a philosophy course, is what we're discovering is that there's certain, almost what look like symmetrical relationships between the statements we make in our reasoning, such that it looks like what we're discovering is certain patterns that are embedded within reasoning itself, within our very thought procedures. And this is utterly fascinating, which means that what we're doing in logic, though it may seem fairly formulaic, is we're coming to a basic understanding of how and what it means to think, right? And if you don't find that fascinating, I don't know what is, right? I find it very fascinating. Okay,